So we'll feed the lipid pig some tag in the mouth. We'll have a decrease in particle size. We'll also have the addition of lingual lipase. And we'll remember that lingual lipase prefers short-chain fatty acids, works on the SN3 position, and remains active in the stomach, even in spite of the low pH. We'll also go ahead and add gastric lipase, which is very similar to lingual lipase in that it prefers short to medium chain fatty acids at the SN3 position. And so in the stomach, we have this tag. Sorry, I had to move my keyboard. We have this tag, and some of the tag, albeit a small fraction, is becoming DAG plus free fatty acid, or you could just write FFA or FA, but a big chunk of it stays tag. And then all of this heads to the small intestine. We'll draw the line all the way through. That way we're done with that, knowing that some lipid remains undigested. Okay, in the small intestine and in the stomach, we have physical emulsification. We have that again in the small intestine. Okay, and we also have chemical emulsification. Both of these make up phase 1. Chemical emulsification in the pig consists primarily of bile. There is lysolecithin. You guys produce lysolecithin. It's just not in nearly the quantity or of the importance that it is produced in the ruminant animal. So we're going to add bile, and bile is going to stabilize that fat droplet and to keep really large fat droplets from forming, so we can act on it. We have the addition of buffer to raise the pH from both the small intestine and the pancreas. And then we're going to have the addition of, we're going to have the addition of pancreatic lipase, so 2 enzymes, pancreatic lipase, and not really an enzyme, but a helper, pro-co-lipase. And then down here, we're going to remember that for pro-co-lipase to work, it has to be activated. And it's activated by trypsin. Okay. And it becomes co-lipase. So just to kind of remember what pro-co-lipase or what co-lipase does, co-lipase is Maverick's goose, and if you get that reference, you're 1 old or 2 have watched Top Gun. So basically it creates room, it creates a way for pancreatic lipase to associate with the fat droplet, because again, the fat droplet doesn't want to interact with water, so you have to have a protein that's relatively hydrophobic to create a space for the pancreatic lipase to bind. Okay. And then we have phase 2. And phase 2 is enzymatic digestion. And if you want to describe it as phase 3, you can. We're going to have absorption. Okay, so enzymatic digestion, the tag will become DAG plus a fatty acid, and the DAG will become MAG plus a fatty acid. And this is all happening as a result of the pancreatic lipase. With its good friend, colipase, helping, creating a space. Okay? And so what we're going to be releasing is 2 fatty acids, or 2 free fatty acids, plus MAG. And in class we didn't draw this, but you guys know enough now, we can go ahead and draw this. So we draw our little enterocyte. And fatty acids with less than or equal to 10 carbons get absorbed directly in the blood. They bind to albumin. I spelled that wrong. And go to the liver. Okay. Bigger fatty acids, so fatty acids with greater than 10 carbons get absorbed. We reform TAG. We do some stuff in the endoplasmic reticulum and the Golgi apparatus, and that results in a chylomicron. Notice a big difference between the pig and the cow is we can synthesize TAG without the addition of glycerol because we're absorbing monoacyl glycerol. We have this glycerol we're absorbing, so we can, we're absorbing this glycerol backbone, so we can synthesize the TAG without needing to create glycerol from somewhere else. Okay, and then the chylomicron is going to go from the enterocyte to the lymphatic. Then it's going to go from the lymphatic to the blood. From the blood, it's going to go to the muscle. It's going to go to 2 places. The muscle. And the adipose. And in those tissue beds is where we have lipoprotein lipase. And that lipoprotein lipase is going to find the B48 and say, hey, we can do things to you. And so it will interact with that chylomicron, and it's going to release DAG plus a fatty acid, which the adipocytes in the muscle can then absorb. And then from there, we're going to have a chylomicron remnant. Which goes to the liver and is endocytosed by the liver and metabolized by the liver. We're going to have bile absorbed in the ileum, and from the ileum, it's going to go to the liver. With some bile, and this happens in the cow and you and everybody. I don't sometimes draw it, but some of the bile is going to be excreted in the feces. In the large intestine, we can have the same hydrolysis and hydrogenation. that we have in the rumen and the large intestine of the cow and the large intestine of the horse. Again, it's probably not going to be a lot because the large intestine is relatively small. We may have some VFA production from glycerol. And those VFAs get absorbed. And then we could also have the synthesis of microbial phospholipid, which could be excreted. Again, relative to the horse, it's going to be small, very little, and so also probably smaller than the cow as well. Okay, feel like that's pretty good. Little pig.